Hi everyone, I am CHOUDHARY, a grade 11 student from Karnal, Haryana. I cleared INMO this year and today I'll be taking a session on angle chasing. I'll be discussing a few problems which are mainly solved using angle chasing only. I'll be discussing around 5 to 10 problems, depends on how much time it takes. So let's begin. This is the first problem. This is from Canada 1997. The problem says the point O is situated inside the parallelogram ABCD such that angle AOB plus angle COD is equal to 180 degrees, and we have to prove that angle OBC is equal to angle ODC. So let's first draw the figure. So this is a parallelogram ABCD, and we are given that O is some point here. It can be like any point with satisfying the angle condition. And it's stated that this angle, let's say X, plus this angle is equal to 180 degrees. So this angle will be like pi minus X, pi in radians, so like 180 degrees basically. And we have to show that this angle ODC is equal to this one, angle OBC. So now to show this, we can like just directly try to angle chase. We can, let's say that this angle is some alpha, and then this is 180 minus alpha minus X, and try to do various things and use that it's a parallelogram, so the adjacent angles sum to 180 degrees or opposite angles are equal. But that doesn't really help, because that AOC are not collinear. So you cannot say this angle is also 180 minus X, which is like not very nice. So how can we use that these two angles sum up to 180 degrees? You know that in a cyclic quadrilateral, let's say this is some random cyclic quadrilateral, this angle plus this angle, like the opposite angles, sum up to 180 degrees. That's the same thing we will use here. Now to use that, what we do is, since ABCD is a parallelogram, AB equal to CD. So basically we can shift A to D and shift B to C, right? And then shift triangle ABO and let's see where O goes. So basically if you shift, AO will go to like some parallel line passing through D, and BO will go to some parallel line passing through C. So O will be their intersection. Also ignore this too. Let's call this point as O dash. Note that triangle ABO, I'll write it out once. Triangle ABO is congruent to triangle DCO dash. Because of how we translated it, like we translated ABO to DCO dash, right? We can do this because AB equal to CD. Now, since these two are congruent, by CPCT, angle AOB should be equal to angle DO dash C, which means this is also X. Now, notice that angle DOC plus angle DO dash C is 180 degrees, which means DOCO dash is cyclic, right? So now we join OO dash. I'll erase this so that we can like see it clearly. We know that this is cyclic now. Okay, so since this is cyclic, angle ODC should be equal to angle OO dash C, because these are the angles subtended by chord OC, right? And since OB is parallel to O dash C because of how we translated that triangle, and it's equal to O dash C also. We get that OB CO dash is a parallelogram, which means the opposite angles are equal, and hence angle OO dash C equal to angle OBC. So we concluded angle ODC is equal to angle OBC, and this is what we had to prove. So I hope this question is clear, and let's move on to next question. You can pause the video and like try to grasp it if you have any doubts. So this is the second question. It's GMO 2011 problem 5. The question says there is a circle, omega, and 5 points A, B, C, D, E lie on it, such that if P is a like point outside the circle, then PB and PD are tangents. These two are the tangents. PAC are collinear, and DE is parallel to AC. These two are parallel. We have to prove that BE bisects AC. So if let's say this point is F, we have to prove F is the midpoint of AC. Like F is intersection of BE and AC. So how do we do this? One property of midpoints of a chord in a circle is that if like O is the center of the circle, then OF should be perpendicular to AC. So now, if you note that if let's say OF is perpendicular to AC, then angle OFP is 90 degrees. This is what we have to prove, right? So this is called like you're seeing the solution backwards. Basically, like what you have to prove, you assume it to be true, and then see what you can get from it. So as to like reduce the stuff you have to do. Now notice that if angle OFP is 90 degrees, I also have angle OBP 90 degrees. Why? Because BP is tangent, right? So this angle is also 90 degrees. So now if OFP is 90 degrees and OBP is also 90 degrees, which means OFBP should be cyclic. So the question is reduced to proving OFBP cyclic. So let's now try to prove this. To prove this, what do we do is like we first join BD. Like this is an angle chase. You can pause the video and try to solve it, and it can be done in like 5 minutes if you notice the angles quickly. Okay. So let's call this angle. Sorry, yellow is a bright color. Let's call this angle say alpha. So now since PB is tangent and BD is a chord in circle, by alternate segment theorem, since E lies on the circle, angle DBP should be equal to angle DEB. This is what we have. So this is also alpha. And now since DE parallel to AC, using this condition, and EF is like transversal, by corresponding angles we get this is also alpha, right? Now notice that since the length of the tangents is equal, so BP equal to DP. Now in triangle PBD, since this is like an isosceles triangle, this is also alpha, which means since angle BDP is equal to BFP, we get BPDF cyclic, right? Moreover, okay, I'll change color. Since OBP is 90 degrees, this is 90 degrees, and ODP, this is also 90. So since opposite angles sum up to 180 degrees, OBDP is also cyclic, right? So basically, if I draw this, If I draw the circle BDP, since I should demark it. Since BPDF is cyclic, which means F lies on circle PDP. So F lies on this green circle, and so does O lies on green circle because OBDP is cyclic. So can you see OFBP, OFBP are also cyclic. All of them lie on the green circle. So we proved this thing. And this is what we wanted to prove. So we are done. I hope that's clear. And also you should note one thing here, that like in the starting, like how when we were thinking about the problem, we worked backwards. This is what we do while you're finding the solution. But like in an exam, when you write the solution, you write it in the forward direction only. Like here we have found that OFBP cyclic. So now you can say that angle, yeah. So from now you can, from here you can say that angle OBP equal to 90 equal to angle OFP due to cyclicity, and then F is the midpoint of the chord. This is how you write in an exam. So I hope problem 2 is clear. Let's move on to another problem. So this is the third problem. This is ISL 2019 G1. This problem is like not meant to be done on GeoGebra. It's like it spoils the problem mostly, as you can see. But anyways, we'll do it right now. So we are given that ABC is a triangle, and there is this circle gamma. I'll draw it in black, such that it intersects the segment A. It passes through A, intersects the segment AB at D, segment AC at E, and it intersects segment BC at 2 points F and G. Like F is closer to B than G. Then you construct the circumcircle BDF. Let's draw it in green, and CEG. It's also in green. And then you have said that T is the intersection of tangent to BDF at F. This is basically tangent to BDF, and this line is tangent to CEG at G. T is their intersection. We have to prove AT is parallel to BC. So this is what you like make a claim or just a random guess from your own diagram. But from GGB, it's evident that T lies on this circle gamma. This is actually true, you know. If you draw a good enough diagram on paper, also you can see it. So this thing helps us a lot. What we do is, if we prove that if the intersection of F tangent with gamma is, let's say, T of F. So suppose TF is intersection of F tangent with gamma, and ATF is parallel to BC. Similarly, if we prove that TG, like ATG parallel to BC, TG is defined as tangent intersection with gamma. Basically this thing. So for now, let's assume that this is the intersection with the F tangent, and we do not know that if this, let's say, I'll change the color of this line. We do not know pink line is tangent to this circle or not. We just know that FTF is a tangent and it intersects at gamma. So first of all, we do some angle chasing and see that note that this angle, if I say this angle B, then since FTF is tangent, this should also be angle B, right? Because then by alternate segment theorem, angle DFTB or TF is equal to angle DBF. Now, since AF, TF, and A is a cyclic quadrilateral, like all the 4 points lie on gamma, and this angle is A, angle A, we will get that this whole angle plus this angle should be 180 degrees. So you can try this as a like very quick exercise, or like just see it quickly, that this angle will be angle C, like 180 minus A minus B, which is just C by angle sum property. And this is also angle C. So basically alternate angles are equal, thus ATF is parallel to BC. Right. Similarly, we can show that I'll edit the colors. Now let's say this is a tangent. And we do not know if this is tangent or not yet. So if we show that this point, in this case it's like TG. If ATG is also parallel to BC, we will be done. You can try this as an exercise how to show ATG parallel to BC. It's the same idea as we used in this thing. Okay. So we got that ATF is also parallel to BC and ATG is also parallel to BC. Note that if you construct a line parallel to BC and passing through A, there will be exactly one point at which it intersects the circle. So which means TF is the same point at TG, right? So the tangent at F meets the tangent at G at this circle gamma. We call that point as capital T, and we showed that this point is such that AT is parallel to BC. Okay, I hope this is clear. This is basically like, this comes under a topic of phantom points. You assume that the point is like the point satisfies the property which we have to prove in the question and prove the other way around. So like it takes some 2-3 minutes to grasp the idea, or you can pause the video and see yourself. Let's move on to the next question. So this is the 5th problem and the last one of the lecture. This is ISL 2018 G1 and it was also IMO 2018 P1. So the question says gamma is the circumcircle of acute triangle ABC. So this is gamma, the orange circle. Point D and E are on segment AB and AC such that AD and AE are equal. Basically, AD and AE, these two things are equal. Okay, I think it will take time to color them. Yeah, but you get AD and AE are equal. And F is a point such that FD equal to FB, because like F lies on the perpendicular bisector of BD, right? So what it means that FD equal to FB and F also lies on this gamma. Similarly, G is defined like as the intersection of perpendicular bisector of CE and gamma. So GE equal to GC is the thing here. So FD equal to FB and GE equal to GC. We have to show that either DE and FG are parallel or they are the same length. Note that if they are parallel, the same length thing is covered inside that only. Like if two lines are concurrent, they are also parallel, right? So just have to prove DE and FG are parallel. So here's a nice thing which someone taught me, that if there is like a segment and there is one intersection of that segment with a circle, you should also draw the other intersection, because it's like if one intersection is not very nice, the other one comes out to be nicer. Okay, so what we do is we draw this line FD and line EG and consider these points H and I. What we do is note that angle FBD is equal to angle FDB, because FD equal to FB according to question. Since FDH is a straight line, by vertically opposite angles, angle ADH is also equal to FDB. Moreover, since this is like a circle, so angle FBA equal to angle FHA. Like all these points lie on a circle, right? So if I draw this thing, we'll get this is also equal. So note that angle AHD equal to angle ADH, which means AH equal to AD. Right? Similarly, you can get that AE equal to AI, like by symmetry only. And in question, it's given that AD equal to AE. So AD equal to AE equal to AI equal to AH, which means if I draw a circle with center O, center A, and radius D, all these points lie on the same circle, right? I hope this is clear. Yeah. So now how do we finish? Like it's now easy to finish from here. Just note that this angle HDE is also equal to angle HIE, right? Because IDEH lie on the same circle with center A, and angle HDE equal to angle HIE, which is equivalent to angle HIG, because IEG are a straight line. So this thing is also equal to angle HFG, because H, I, F, and G all lie on gamma. So this thing is also. So we get angle HDE equal to angle HFG, which means DE parallel to FG. Also, the last thing which I just did, proving these two parallel after getting these I and H points, it's just known as Reims theorem. You can memorize it also. It's like very helpful in other problems. So I hope all the 5 problems are clear. In the problem set which I have attached, like you can find it in the description, there are 5 more problems which are not discussed, and you can try them on your own. They're also on angle system only.